I'm just going to hit record here. And I guess we can start class, even though it doesn't look like everyone has joined us. Can you see the screen okay?
Yes, I could see it.
Oh, good. All right. So what I'm going to do is I'm going to hide my floating meeting controls. And then I think what we'll do is go through some of the stuff for the course here. We've got, I had a homework due last night. Were you able to do it okay?
Are you talking about the homework? Unfortunately, I thought the homework was due tonight, so I did not complete it. I was going to actually ask you for an extension tonight.
Oh, let's see. Look at the options here. And this is due on the 8th. So this is homework number 7. That's due on Wednesday, end of day.
On the 8th. Yeah, I thought it was due the night of your class. So I think it was like homework 7 I didn't do. I'm pretty sure I got a few texts from other classmates like Costa. I believe he thought it was due tonight as well. So
homework 7 is due on the 8th.
Oh, homework 7 is due on the 8th? Okay, I got a notification or is it homework 6? I got a notification this morning that
homework
I was
6
late.
is was due yesterday.
That's what it was. I apologize. Yes, homework 6 then.
All right.
Is there any way you could extend it by a day?
Until, yeah. How about we make it display until tonight?
That sounds good. Thank you. And if you want, send a quick email out to everybody because I'm not sure if everyone knew that. I don't know. We might have gotten our days mixed up with Uma.
Yeah, I'm going to send another email out that just says subject homework 6. And then what I'll do is I'll write out, hi all, I have extended. Actually, if people came to class, I'd be able to tell them without having to send an email, you know? I have extended homework.
True. I just saw your email about it last minute as well, so that's why I joined.
Homework 7 is due March 8th, Wednesday, end of day. And the midterm is due March 22nd. Thanks. Yeah, people should come to class, you know. All right, so there's that. And now what we got here is, let's go back into this here and we'll look at the homeworks. So here's homework 6. It's on design patterns. I think you get 2 attempts. Let me just make sure. 2 attempts, and we'll do the highest grade on the 2 attempts. Highest grade. So that should be good. Due date tonight. And that should, all your answers, the correct answers, feedback. Good, submit. That's 2 attempts. So then comes homework 7. Let's look at that and make sure you got 2 attempts here. And 2 attempts, highest grade, due on the 8th, which is a Wednesday. So homeworks have always been due on Wednesday evening. Let's see, what else do we have here? You got all the answers all at once, hit submit. Okay. Then comes the midterm. Midterm test options. What we'll do, highest grade, number of attempts 2, display after March 1, that's yesterday, display until March 22nd, that's Wednesday. So that gives you some time, right? And then what we'll do is we'll make it due on March 22nd. And then you get feedback, 2 attempts, unlimited time, open book, open notes, and all at once. Submit. So now you should be seeing homework 7, homework 8. No, not homework 8. Homework 7 and homework 6, and you should be able to see midterm. Does that look all right to you? Are you able to see that on your screen?
I can see it on your screen. Unfortunately, I'm driving home right now, so
You're
I'm just on my
driving.
phone right now.
Oh my gosh, you're driving. Okay, so let me go into the student preview mode
Yeah,
and see what
I
it
can
looks
take a
like.
look later. I can take a look later and verify for you, but I just can't right now.
No, I hear you. I hear you. All right, so I'm in student preview mode. I can see homework 6, homework 7, and the midterm. I'm going to exit my preview. And back to the course content. And so that's that. So now you've got homework 6, homework 7, and a midterm. That should basically have you all set until March 22nd. Does that sound good to you?
Yep, sounds good to me.
All right. So then if you're not able to see anything, and nobody else is online, what I'll do here is I'm going to go through. Have you looked at homework 6 at all?
I have not.
Okay, so homework 6. Let me ask you this: do you remember any probability?
Oh, slightly, very small amount, to be honest.
All right, so there are some videos here about Bernoulli theorem. These are this has to do with binary experiments, like flipping a coin. And then there's the large number theorem, Bernoulli theorem. It's in the limit. As you flip the coin a lot, you start to get what they call a Poisson distribution. And I'm explaining this to you while you're driving in the car. I hope there's not too much traffic.
No, there's not.
Okay. And then what we do in probability is we make use of this distribution to model arrivals of packets into a server. And the server has a queuing discipline, which is first come, first served. And that's called an MM1 queue. So it has Poisson arrival, Poisson service, and a single queue. And then we generalize it to multiple queues with Poisson arrivals. And that gives us the ability to essentially model the capacity of the server so that we can figure out how big to build the server. That's the basic idea. So there are 30 questions here. There are some that are based in the probability, and there's a review with the video here for you to watch. And then there's some Java questions. And so what I did here was I gave you some videos on design patterns. And so are you familiar with the term design pattern?
I'm not. Can you explain it? Unless I'm thinking
Sure.
of something else.
Yeah,
It's not like design pattern like homework 5, like what we did with the interfaces, right?
yes, exactly. So in
Oh,
effect,
okay.
like singleton design pattern, that sort of thing. So if you wanted to create a standard for the design of your software, you might give it a name and a purpose and a basic algorithm for implementation. So for example, with the singleton design pattern, you have a technique that allows you to make sure that there's only a single instance of your class. So that would be, you make the class final, so it can't be subclassed. You make the constructor private, so people can't instance it from outside the class. And you create a single accessor like get instance, and that will return the instance that was created internally to the class. And that's a class that's designed to make sure that you have only one instance of the class available. So that's a basic design pattern. And so I have a video with the intro to design patterns that everybody can look at. When I built this little database system for my address book, I made sure there was only a single database, that singleton pattern. And then everybody gets to access that one database, and it allows for consistency so that when the database gets updated, everyone sees the same version of the data. So that's a design pattern application. The model view controller design pattern, that's the one where the model might be something like a number, and the view would be like the gas gauge. So the number might be how much gas you have. The view is the gas gauge. The controller might be something like your gas pedal. So you're driving your car down the road, you have a model view controller. The gas gauge does not allow you to change the amount of gas that's in your tank. The only way you can change the amount of gas in the tank is by turning the car on and running the car. And presumably you turn it on with a controller like an ignition key, and you hit the gas pedal and it uses gas. And the model is just the amount of gas in the tank. So that's a design pattern, model view controller design pattern. And it's very common to have something like that in a Java programming environment. The mediator design pattern, that's the one where you connect observers and observables. So you might have a bunch of things that are interested in how much gas there's in the tank. So the gas in the tank, that's observable. And the thing that's observing it might be the gas gauge, maybe you're running low on fuel indicator, the thing that blinks on your dashboard. Maybe it's the thing that computes what your miles per gallon is. That's another view. So none of these things actually change the model, right? So model view controller is in some sense connected by a mediator. So the mediator is like the wiring closet. It's like an Ethernet hub where it hooks all these things together. That's what the mediator does. So that's a sort of a basic idea behind the mediator design pattern. Let's see now. Let's see. I'm just going to go through the homework here. This is giving you some theorems, which you will be able to get if you watch the video, which I cannot play for you because you're driving. Do you know what a keyboard modifier is?
Not off the top of my head, no.
All right, so like when you hit Alt, Control, Delete.
Yeah.
Those are, Alt and Control are keyboard modifiers. Delete is the actual key.
Gotcha.
Shift is a keyboard modifier. D or A through F or A through Z, those are all keys, right?
So they allowed like a secondary function or third tertiary function.
Yeah, I mean, they allow you to modify the value of the key. So taking a shift button to modify and then hitting the A key makes a capital A out of a little a. So that's a keyboard modifier. There's a meta key, an alt key, a control key. They're all keyboard modifiers. And you can intercept these things when you're building a graphic user interface in Java. Does that make sense?
Yes, it does.
Okay. So let me see if I can get through some of this stuff. The term arrival usually happens at a rate. So customers will come into your store at a rate which you can average. And their typical distribution is called a Poisson process. So that's a probability distribution function that is described by the average arrival rate of the customer. So you might get something on the order of 10 customers per hour, right? But then the rate at which you service a customer once they walk in the store, you know, can I help you, ma'am? Can I find you something? What are you looking for? That sort of thing. That could take you 5 minutes per customer. So you have an arrival rate and you have a service rate. This allows you to compute the expected number of customers who are waiting. And so what you do is you take the arrival rate, let's say it's, I don't know, make up a number, 10 customers per hour. And the waiting time is the amount of time, or let's say the average time the customer spends waiting in the system. And so that's including the service time. So usually it's something like 1 over the service time minus the arrival time. So if the service time is once every 5 minutes, that's actually 5/60ths. Is it 5/60ths? 5/60ths of an hour. And if the customers come in at 10 per hour, then that's once every 10 minutes. So if you had, I don't know, is it once every 6 minutes? 10 per hour is once every 6 minutes. So you have service at 5 minutes. You have customers coming in once every 6 minutes. And so then you do a computation to get your waiting time, which is about 1 minute per customer. You get the number of customers coming in per unit time, whatever that may be, 10 per hour, something like this. And then you can expect what the actual length of the queue is going to be. So you can estimate queue length as a result of this. And so that's sort of a 6 minutes per customer is 10 per hour. And you get to compute what's known as the rho, which is the intensity. So that's the average arrival rate divided by the service rate. So that's 5 customers per hour divided by 6 minutes per customer. And so you get a number on that. And I can show it to you, but it's hard to explain on the phone, I think. So that's one of those things where you kind of have to see it. It'll once you see it, I think you'll understand it. So I'll put it that way. And anyways, the goal is to use a couple of equations to try and compute the average waiting time and the average length in the queue. And once you're doing that, you're basically through the hardest part of the computations, and it's really just arithmetic. So it's just addition and division and multiplication. That's it. Let me see what else there is here. Have you tried using any of the swing interfaces, like scroll bars?
Have I from your source code from your from Blackboard? Are you talking about?
Yeah.
Yeah, I played around.
Or even in your prior classes.
So in my prior classes that we did Java, we didn't do so much like user interface. It was more just like a 2D type of thing. It wasn't anything like buttons and things like that. There was no interface. If that
I
makes
see.
sense.
All
Yeah.
right, well, you know, if you go into the graphic user interface package, you should be able to find some things called run scroll bar, run
Yes,
slider. You found that?
correct. Yes, sir.
Oh, good. All right. So yeah, if you run, like, for example, I'm running the run slider right now. It'll give you a series of different sliders, and as you slide them around, you'll see some values coming out. I'm doing it now. If you had seen it, you know, sort of, I would say it would be immediately apparent to you, but because you're driving, it's a little difficult. But effectively, imagine you were you know, running some sliders, and you could see numbers coming out.
Yeah, I already played around with it, so I do understand what you're talking about.
Cool. That's good. Yeah, I've got a bunch of sort of examples of all this stuff running. And so it's very good if you can try it. And it sounds like you have done. What I did was I turned each of these graphic user interfaces into an anonymous inner reference data type. So you say something like new run scroll bar, and you'll see like there's a run method in there. And then you call get value, and it gets you the value off the scroll bar every time the scroll bar changes. So that's the bird's eye lowdown on the scroll bar caper. And so there are a few questions about that in the homework. And that's about all I can do to cover this particular homework assignment. Yeah, there's another homework assignment coming up for next week. And I guess the thing to do would be to maybe try and go through some of that. I know it's difficult because you're in the car. I think doing this class, I normally consider it a very visual thing. So doing it when you're in the car just sounds hard. But anyway, let's look at homework 7 together, and I can do that.
To be honest, I think a lot of people didn't show up, and I saw your email last minute, to be honest. It's because I think everyone thought it was going to be a recording just posted. So that's why I think no one's here.
Well, there are a lot of posted recordings for people to watch.
Yeah.
So there is that, and certainly you can watch the recordings. That's fine, and maybe people prefer it that way, and then we can just treat this as kind of an extra help session, I suppose. We're inverting the classroom because we've got the recordings, and that's fine. I don't see anything wrong with that. So what I'm doing now is I'm just sort of scrolling through this homework assignment. This is called homework number 7, and it says Poisson threads, layout, and network programming. And what it does is it shows you the connection between Bernoulli trials and an exponential distribution, and it's called Poisson's theorem. And so I give you a proof and some results from Little's theorem, which allows you to equate waiting time and queue length. And then I get into like socket programming, which I think is really interesting because it lets you build a web server and do distributed computing. And finally, I have a video here showing a port scanner in Java, which will take an IP address and scan all the ports and see what's open, which is really good if what you're trying to do is find out what services are present. So that's homework number 7. There's a couple of simple probability computations there. And I guess that's about it. Let me see if there's anything here that I should be covering. We did some threading already. I think we had a nice PowerPoint presentation on threads.
Correct.
Yeah, you might have been there for that. And let's see what else. I show how to read in numbers from the console. So I'm using a thing called the scanner. So I do scanner.nextInt, and it just reads in a bunch of ints. Let's see. We do Poisson distribution. And then I talk a little bit about a computable object. Computable object is something that you can pass back and forth across the network. So you can pass in a computable object that gets computed by some sort of a compute server, and then the answer is returned. So that's that. I think we already talked a little bit about the layers, right? There was 7 layers in the OSI layers. Does that sound familiar?
Yes.
Okay. All right. Let's see now. I did some error correcting codes. One of the error correcting codes is called the Hamming code. And the Hamming code is used to try and detect and or correct errors. And so if there's just one error in the Hamming code, it can correct it. If there's more than one error, it can detect it. And you can make the Hamming code a little bit more aggressive if you like. And so I did a nice video about Hamming codes and how you can do digital data transmission and error control. So that's that. And that takes you through, well, it takes you through basically homework number 7. So what I was thinking is I'm going to make an announcement to the class that people should tune in for a review for the midterm, because I think people are going to need that, and we don't have too much attendance here tonight. You know?
Yeah,
And so,
I think being sent out before the midterm, like next week or sometime soon, would definitely benefit the class for sure.
all right. So yeah, I sent out an email telling people that they've got this homework 6 extended, homework 7 due next week, and the midterm due on the 22nd. And hopefully we'll get some good attendance at our next session. And so that's kind of where I'm at for now. Do you have any questions for me? You're still driving, I guess.
Yeah, I'm driving actually back from school to home. I currently don't have any questions for you now.
All right, very good. Well, if it's all right with you, then I think maybe what we'll do is we'll sign off for now. And I'll send out an email telling people that the next class will be the midterm review.
I understand. Awesome. Have a good night.
Thank you.
Thank you.
You too. Bye-bye. Drive safe.
Bye. Thank you.